Okay, so let's start. About embedded systems, and let's see, starting from today, we will have 15 lectures, and we will cover the topic of embedded systems. So then we will discuss about, we will introduce the topic, and we will discuss about the architectural concepts of embedded systems. Let's try. So now here is my profile. What I use to create these cards, because usually my motivation comes that I was when I finished my studies on Technical University of Moldova, I had a big problem that when I go to the industry side, or so I had a big problem that I have seen that what I learned in the university didn't help me in my job career. Why? Because sometimes they explain me what to do, but the biggest problem was that I don't understand why I need this topic. Now, in the process, in the learning process, when you don't know why you need such things that you are learning on the curricula, usually the process of learning is related more to learn by heart, pass the exam, and forget. In Russian will be Z в кубе. Зазубрил, сдал, забыл. Okay, maybe it's not the most proper way, but this is actually the process that usually happens in the learning process in the university. Why? Because you don't have this answer on why. So now, coming back from the industry, because I started an internship on digital design and verification in Romania, and I realized that on their side, they are using different type of methodology and different type of tools, skills, and so on. So on our side, let's say on our country, usually digital design or electronic design, usually we are doing by pen. They started to use hardware description language to develop, let's say, to design on CPU or on processor. So now I got this point, come back because of some circumstances, not because I didn't pass, but I just said, let's start to learn together in different ways. So now, according to my experience, I introduced many topics in the university that are well related from starting from the hardware description language, Verilog, how to design a digital system starting from the logical gate. Logical gate, you know what is logical gate. It's usually implementing on the logic function, basic logic function. What are the basic logic functions? And or not. XOR. So now let's see, combining, we will have a combinatoric logic that we can implement any mathematical, let's say, relation or arithmetical logical function. That means we can evaluate any function. But this is combinatoric logic that we have an input, provide an input and get an out. Most probably you have had such course as analysis, synthesis, discursive development for digital. Okay, but now having this logical gate, having a feedback, or say on a closed loop, we go to the next level of the autonomy of a system. That means we start to memorize. So we will memorize, that means the output will be regenerated to the input. So we have the function of memory. Yeah, with a logic gate, and we will memorize 0 because we know that 0 and anything else will have always 0. Yeah. Now we'll have the similar logic gate like OR, and everything OR 1, we will have 1. So we'll have a closed loop to memorize 1. Now combining them, we can memorize 1 and 0, and most probably you heard about the restriction. Yeah, so this is the basic memory cell. And now, having this memory cell, we can memorize, we have combinatoric logic, put them in a closed loop, we will have an state machine or automat thinking, I don't know, state machine. So now, finite state machine. So now what that means, we have combinatoric and the evolution of the state and the memory. Having this one finite state machine with another, we can build a processor. Combining, adding another closed loop, we will have computer. After that, network and so on. So this is actually the philosophy how to build digital system. Next level I achieve is the microcontrollers and interfaces. That means, okay, we build a microcontroller. Let's see how we will transfer the workload from the digital design, so from the hardware, and to transfer complexity to the software. So, okay, we have a processor and we have some assembly instruction. Who knows what means an assembly instruction? What is
definitions of syscalls?
what?
Some definitions of syscalls and both syscalls of the package.
I don't know how to interpret that, even because it's not a syscall. Usually, yeah, please.
It's a kind of human readable way of writing
Binary code. Yes, maybe somehow yes, but usually an instruction is a mnemonic that has a equivalent in binary code, and let's say addition will have 0x05. This is the number of it. But we have by compiling assembly language is a kind of find and replace, nothing else in compiler of assembly language. We just convert 1 to 1. But usually assembly instruction is a configuration of the microcontroller. So we have the processor. We have a configuration, we'll see in one of the slides, but this is the configuration that, look, take first register, second register, configure to add this, evaluate that. So after that, program counter will go to the next configuration. So what is a program? What is a program?
Sequence of instructions.
Sequence of instructions. Now we have assembly instructions, and we have this program. But what is the difference between a simple program and an algorithm?
Algorithm is fine.
A program is a sequence of instructions, nothing else. Yeah, we just have a program, but algorithm is a sequence of instructions that are logically ordered to solve a problem. So not every single sequence of instruction means we have a solution. It's a kind of, there is a joke like you'll put a million or a billion of monkey that will hit the buttons. At certain moments, we'll have some program, some sequence of instruction, let's say like this. But maybe in one day we'll have even something that will be useful. So usually this joke is like we can say that writing code or writing some instruction is a monkey work. Now depends. Will you put some logical ordering of this instruction? So from the monkey, or difference between monkey and engineer, an engineer is thinking about what he is doing, not just pressing the button. So for me, I try to associate that just writing code is a monkey work because first you have to think, to define what you want to do. Now we have a good chance to go through the problem-based learning, identify the problem, identify the solution. And after everything is defined, everything is known, you can go and outsource your project to some monkey to hit the buttons. Yeah, but usually, okay, it's it's an ugly joke, but let's go from this perspective because what is the one of the most important skill of an engineer?
Problem solving.
Laziness, yeah, because most probably we already discussed this topic. Laziness. And Russian will be, чтобы такого сделать, чтобы ничего не делать. Yeah, so let's have the simplest story. In the ancient time, I don't know, some people to do something, to bring some stones, they just carry. And one of them that don't want to carry just hit a stone and it start to roll. Yeah. Wow! Что так можно было? Okay, after that somehow he insert where there's something and build a carrier. After that a bicycle, after that a car. But why? Because engineer or these people are lazy. They don't want to work. They want to build something that will work for them. So this is one of my crazy beliefs. Yeah, that you have to be lazy enough to be smart. Okay, so now, there are other things. So next level after I know how to program. Next step was the embedded system. Now I have something that is thinking for me because I'm solving once this problem, put a microprocessor to think instead of me. Now I want some smart things. So what I can do, I can insert some smartness in some things and I will build some smart things that will think for me. And I just will say, I want something and this thing, I don't know what name it could have, let's say a smart car. He will bring me something from the store. Just say, I want some bread. Yeah. He just will take as I input my wishes, and after that he will solve according to some algorithm, some program sequences. Yeah. So this is about the embedded system. So I'm embedding some computer power and some things, and it start to be a smart thing. So embedded system is about the embedding smartness in some daily life things. Got it? Yeah? So now the next step, what? This is about my rules. So I know that there are a lot of things. I try to bring them together to solve some problems. So I build an internet of things, but it's also related to the embedded system. It's a big system over systems. Yeah. So, but this experience usually I bring from the industry. I held many positions from computer, let's say, programmer, but finally, digital design, digital verification, some EDA, electronic design automation. So that means we developed some tool that is helping electrical designers to draw the schematics, yeah, and the layout. But one of the most or the biggest inspiration job was the automotive domain, because what I, from my experience or from what I see is that, did you realize that some of the families has one vacuum cleaner and most probably they will have 2 or 3 cars? Did you see such situations? On my house, we have 2. One of car, the third is broken, but I have only one vacuum cleaner. This is from my experience. So now let's see. Comparing the volumes of production of cars and vacuum cleaners, we will see that they are on the same level of magnitude, let's say, on the same order. And we see vacuum cleaner is a simple technology, yeah, and the production is somehow comparable with the car developments. But let's see what is actual a modern car, what kind of technology they have. They have high technology with mass production. But now, what is a car actually? I compare a car with a bullet that is flying on 300 kilometers per hour, yeah, and usually everything it touch destroy. But usually it can be, let's say, but you are in this bullet, and in case, let's say, the target will be stronger than the bullet, so that means car usually kill. It's a high probability that will kill people. So in order to manage this situation, we have to insert some not only smart technology, but reliable technology and safe technology. So that means our code will not, should not have situation when, are you sure that you want to brake? So, and on 1 kilometer per hour, 1 second is it will come to that. That means in case you will lose the lights in the night on 100 kilometer per hour, in 1 second you will be dead. So that means you have to react immediately to analyze everything. And it's not about we know, everyone knows that, okay, I have machine learning, okay, until camera will analyze, maybe we'll have some analysis, checking, and so on. And after a few minutes, I will have a good result. In automotive technology, that will not work. I have to react in 10 milliseconds. Otherwise, I will have somebody killed. Yeah? So this is actually what is inspiring me to do the things right. That means my code shall be very simple, fast, and reliable. So now this is actually my profile regarding the studies. Finally, after 15 years, I finished my PhD studies. So actually now I'm doctor of philosophy and embedded systems. But let's see what is an embedded system. We have some definition from Wikipedia. Yeah, we have an embedded system is a computer system, somehow combination of computer processor memory, but it's about architecture. But we want, and now, you know, and my, how to say, leadership, or how to say, scholarship, I thought that math and physics is more important than other subjects. But finally, when I start to think, I understood that philosophy even is more important, because what is the definition of the philosophy as a subject? I don't know. I don't like it. But I start to understand that first you have to. It's Helio and Sophia. What?
Love of wisdom. Love of wisdom. Yeah.
Love of wisdom. What is wisdom actually?
It's an opportunity.
It's an opportunity. Господи, dragostea de a cunoaște. Yeah? So you have to know first to define what you want to do. So the first, and you know, maybe it's not for the protocol, but the main question that in the university, I think, shall be answered. I don't know on which level they answer you, but is the question, what is the question? Why I need that? I will say even more critical, yeah? Нафига? So I have to learn math. Why? I have to learn physics. Why? Because in case you don't know why you need this subject, then you will not apply it. You just will apply the formula Z on cube, and that will be end. You will just pass the exam, and I know in case you don't know, don't like a subject in 2 weeks, most probably you'll forget that. And even you have 10. So that means your mark and your diploma doesn't cost anything. It's just at certain time you teach cum spune, stișoc. O poezie. You forget about that because you don't need even that. But now when you understand why, let's say, I want to build a car. Wow, but in case I want to build a car, I will need to understand, I'll have to understand how the car is driving. So why the wheels are round, yeah? Because this is why, but why, what is the length of the this circle, yeah? And we try to understand and we will see, okay, now when you will try to understand such things, you will say, okay, I had a subject, geometry, math, that will help me to solve problem. Then I know why I'm learning math, geometry, and so on. Good idea. So now this is, you are happy because you have this special subject, problem-based learning, because you have where to apply your knowledge. So please use that. Define a project. Doesn't matter if you like it or not, but you'll be challenged to apply all your knowledge. It's a kind of, I'm asking my kid about the, why you want to go to the gym. Because I want to be strong, I want to be fashion, I want to be so. It's the same for your brain. You will not use it, it will not be strong. And then you will not have, let's say, a situation, because we are learning by mistakes. You have to do mistakes, because I think that, okay. I think that in case you solve a problem from the first time, most probably it was by not by mistake, by accident, yeah. Because most probably a similar problem will not be from the first time. You're just lucky that you got the result from the first time. But usually you know about the Edison, who invented the bulb. Do you know on which iteration he succeeded? About 1 or 10,000, something like that. And what that means? That means that you were mistaken 1,000 times. No, I know 1,000 of solution that will not work. Yeah, so mistakes, usually people learn from mistakes. But okay, let's go. An embedded system, from my definition, but let's say, what means a definition? Definition of the definition. The explanation, but usually you have this explanation and you teach or you learn it by heart. Yeah, and it doesn't have a sense when you learn by heart, because you learn some words that are associated with this definition. But definition itself should be like, I'm defining something. It doesn't matter what word you will use. So for me, definition of an embedded system is I'm embedding something in something. And in case of this technology of electrical embedded system, that means I embed some computer power and some electrical device. In this case, yes, because depends now what is the question. Yeah, embedded thing, yeah, or embedded device. That means in this device I embodied. I inserted some computer power or some smartness, and it became smart. Yeah. So now you will see such things as embedded system, maybe some devices like this, but usually this is the body and we have some smartness here. But now it's not enough. Okay, we have on the, I will switch to Romanian for 1 minute. La Ministerul Învățământului este o dispoziție prin care se spune că în instituțiile de învățământ, în timpul orelor, este permisă utilizarea dispozitivelor electronice dacă ele se folosesc în scopul cursului. În caz contrar, ele nu sunt admise. Vă rog frumos, dacă voi sunteți, ce înseamnă prezent? Prezent înseamnă că voi sunteți în sală, mă ascultați și aveți posibilitatea să-mi dați o întrebare. În cazul în care voi vă ocupați cu altceva, eu consider că o sunteți absent la lecție, pentru că eu nu cred că voi vă puteți focusa la multe lucruri. Dacă cineva îmi spune mie că el e multitasking, eu nu-l cred. Tu multe lucruri poți să le faci prin automatism, spunem așa, da, să mă scarc în acolo și totodată să vorbesc, dar nu pentru că eu am vrut să mă scarc, pentru că așa mi-e reflexul. Da? Deci de asta, eu dacă văd că cineva se uită în calculator, înseamnă că el împarte timpul ăsta, înseamnă că îți punem jumătate de prezență. Deci vă rog frumos, asta este rugămintea mea insistentă și o fiță de asta de mea. Urăsc când cineva nu mă ascultă. Dacă nu vrei să mă asculți, fii cinstit, spune în față. Eu nu vreau să vin la ori. Aici afară. Dar dacă te-ai înscris la programul ăsta și ai cursul ăsta, poftim. Dacă nu, sunt proceduri legale prin care te duci la decanat, spui că mie cursul ăsta nu-mi trebuie. Deși mi l-ai dat. Și eu să-ți răspundă de ce și alte chestii. Am înțeles? Dar eu vreau, pentru că, credeți-mă, după o oră jumătate de lucru cu gura, da? E foarte greu, după asta îmi sună mai ceva ca la discotecă în cap. Dacă vreți, uite, dacă nu, încercăm așa, facem o practică. Fiecare dintre voi pregătește un speech de 20 de minute la tema care vreau dau, încercați 20 de minute să stați în sală, de eu la și el spun să vă deranjează și să nu vă asculte. Și eu după asta să dau test la temat și să vezi uite nota ta, e ce testul din clasă. Sunt multe chestii, dar am spus, vă rog frumos, acum insistent, închideți calculatorul. Sau ieșiți din sală. Și asta de fiecare dată, hai să luăm așa, că închipuiți-vă. Domnișoară, vă rog frumos, închide calculatorul. Da? Calculatorul în fața ta? Ok, pauză, mergem mai departe. Okay, so let's go back. Let's go further. But let's see what is that, what we see here. We have an application smart home. What means smartness of some things. Okay, and in case of a smart home, what you define is a smart home, or how you think, what is your perception of a smart home? Yeah, please. Okay, one answer. Anyone else? Smart home. When you hear about the smart home, what you think about? How you see that?
Automation.
What?
Automation of some mundane tasks. Like just
Automation. Yeah, okay. Something else?
Don't need internet, like my box connected to the internet. Or some additional.
Okay. Else? Here, so you should use the computer. Please, if you like computer, I will give you some class. On the computer, I will send you the link. You will learn that from there. After that, you have a test. Don't hide the computer. Please remove the computer from it. Eu cred că voi, din primele cuvinte, m-ați înțeles. Dar dacă voi nu m-ați înțeles, uite, eu am așa o sticală. Băieți mei se duc la școală și eu le spun așa. Uite, când cineva te lovește, da? Sau te ofensa, el îți dă ție dreptul total să procedezi la fel înapoi, el îți arată cum trebuie. El spune, cu mine trebuie așa să procedezi. Dacă voi nu mă ascultați, voi mi-arătați mie. Nu trebuie să mă ascult pentru că eu nu te ascult. Acum este alt moment. El când te-a lovit, el nu te-a întrebat și el este lovit. Dar spune, uite, lovește-mă și te să lovesc. Păi, ești ușor, eu dau timp. Nu, tu mai lovi. Părți-mă. Exact așa. Dacă voi aplicați un oarecare disrespect față de mine, care eu vă l-am exprimat, și nu m-ați întrebat, mă aveți înapoi și îmi las tot dreptul să procedez cum vreau eu. Deci, mai bine ascundeți-mă. Bun. So let's come back to the smart home. When I'm speaking about the smart home, and now here most probably I will come back to the philosophy. So what means a smart home? And usually the answer, and most probably you heard about that, is in the question. Smart home. That means we have a home. That is what is a home. And now let's go back to the, I don't know, philology, not philology. We have a sentence and we have what is home in this sentence. Is the subject of the action. Yeah. Smart what means? Adjective e parte de vorbire, nu e parte de focus. It's an attribute, it's an property of the home. So now when we are speaking, we see that it's very important. And now, do you remember your object-oriented programming? You have some objects, and you have some properties, and you have some methods. Methods is what object or subject can do. Properties, what is about the problem? What properties are? How the object or the subject is. Now, I understood that in engineering, sometimes philology, let's say Romanian, is sometimes even is more important than physics or math. Because, okay, for the physics, I know the law, I will not discover a new law. I will just use that when I will need. Yeah, and the math, I know there are a lot of formula. Maybe I can manipulate, but we see that ChatGPT can manipulate formula better than us. But what is important in engineering? What engineering is an engineer is doing?
Innovative.
Innovating. Something else?
And
Inventing. Okay, engineer, you're usually creating something, yeah, something new, and he tried to understand. But first of all, when you don't know what to do, then you will never do. And usually, write a program, and you will write something. I don't like it. And in one certain moment, you will ask me, but what kind of program? What kind of program you want? And you start to speak, and you start to speak, and when you are speaking, you are defining some requirements. And in these requirements, usually you have some sentences. And in this sentence, you have in this requirement, you have the subject, you have the action. The system shall do something, and so on. Okay, the system or the white bulb. I know that I have a bulb. This is the subject. White. I know the property. Yeah. Shall light. I know the action. And now, in case I will not be able to build a clear sentences that has a unique understanding or for all the people, then most probably will have different interpretation. So now, for engineering, is very important to know, to speak, to define, to write clear requirements, clear sentences. Now we see here, smart home. I don't see here in the definition of the smart home that I should have devices. I know that this home shall be smart. Now I come, I'm entering in the smart home, and this smart home says, wow, Andrei, I see that you are so tired. Okay, I just prepared to use some coffee, yeah, or some coffee because you have to work. The home is starting you to play some music to relax to you, yeah, or preparing for you. But what is that smartness, that or intelligence, let's say, yeah? How you define intelligence? Are you intelligent or not? Yes, of course. Why? You can process information, okay? Yes, it's good answer. Once again, please. Okay. Smartness or intelligence, what do you mean by I want us to think about, let's start this gray substance to flow, because after that you will feel by inertia you will start to learn better. But let's start this wheel. Okay, what is a acting? Acting is doing something. And of course,
No, spread like what?
Indeed.
Then.
so now
Instead of going.
let's think differently because yes, of course, we can say we can ask ChatGPT, he will answer us, but my point of view, intelligence is the property of a subject of a system to analyze the information and to make some conclusions. That's all. Let's keep it KISS. You know the principle KISS? Stupid. Yeah, that means we are analyzing. Okay, to analyze, I have somehow to gather the information, all the information I need. I have to decide, even analyze what I have to analyze. Yeah, but I'm analyzing. After that, I have a conclusion. Conclusion, press the button to open the door. That means analyze and open the door. But intelligence is about analyzing and making conclusion. Now we see here a smart home. We see here a lot of technologies that are making this, let's say, increasing the smartness of the home, because we don't know what is the level of things that we can say is smart or not, as intelligence or not. Yeah. And now I want a new feature. I want new skills. Then I will add some technologies here. Now, in case I have a computer, it will not heat my room. I will need something different, another technology for heating. And now the whole system using all the technologies that inside will decide to heat the room if it is required according to the conclusion. Conclusion that comes from analysis. Now let's come back. Could we have, now we have this technology, we have a lot of abilities, we have a wall that can show some images. We have some information portals. We can use it through a smartphone, tablet, or even from a radio, but it's about the source of information. And home is speaking to me, is showing me, is hitting me, and so on. Good idea. Smart home, that means it is analyzing, making conclusion. After that, this conclusion is to make an action. But everything else is about devices. We have some automations. Yeah, it's different. Automation, when I have something that is repeating and automate some process. If the temperature is lower, higher, yeah, but it's not about the intelligence. Intelligence is about the analyzing and making conclusion. So now let's think about this smart home. Let's go few centuries back, and when we had some 17th or 18th century, yeah. Could we have in such? What technology they used to play this scenario? The home somehow knows, or somebody or something from home is helping me in my daily life. Slavery, yeah. At that center, this was the technology. Now I'm buying some robots from the home, and few centuries before I could buy some technology. And you know, that technology was even smarter than today. So our smart home is not so smart actually. Yeah, but now we fight because we are not allowed to buy slaves, so we have to think how to build some. So now other applications. So now thinking about the Internet of Things. When we are thinking about the Internet of Things, we are saying, okay, we have different smart things. Now we want some bigger system, so we'll have some system of system. That means internet. But let's go back now in the definition, because you know better. Usually in a project, when you'll go or on an organization, one of the first thing you meet there or they provide you to learn in a good company. Is the dictionary of the terms. Let's see what, from your point of view, is internet. Internetwork,
Network of networks.
a network of networks. Other, I don't think that there is any wrong answer. It's only the perspective that you see according to your experience. In case the answer is not sufficient, it's because you didn't see sufficient situations to let's say to reach your to enrich your knowledge. Yeah. But now another answer. What is internet?
The connection of all the devices that exist.
Okay. You? Don't be afraid because what you start to think, but even you are lazy, you don't want, you will think and you'll gain more experience. So what is internet? All the answers are correct. Depends of your perspective, what you know. Yes, internet is about the connectivity, interconnection. Now, in case that device or not depends, because internet, I will say internet of people, but I have some technology I see in the Skype. So now I'm on the internet, I'm online. Okay, phone is online or me who is online? So it depends, internet or technology, or now we have different aspects of the internet. We have the hardware, we have the software, we have some technology, but usually it's interconnect people. Yeah? So internet is usually for interconnect some subjects, better to say. It could be human, not human, but to provide or to interconnect subject to transfer some information. It's about the information. So it's connectivity to transfer information. Now, what technology we will use? Because yes, internet that we know is the internet from using some wires maybe. But let's see, did we have some internet few centers before? Did we have connectivity? Yes, we were able to send some messages, different technology, some forces, some lights. We know in Roman Empire, in few minutes, we know that the enemy is on the border. How?
Fire.
Yes, but it was very fast. It's not so fast because they didn't have yet electrical cars, but about the information, they know that something happens. Yeah, but this was the level of technology. So, but now let's think about it's about the internet. And only in the 1992, it was the first network or one of the initial network. And now we see that device is connected to the actual internet. With kind of, I can count it by my fingers. Maybe I can have some my colleague fingers, but that will be enough. Now let's collect all fingers here. So now we see that actual connectivity is very high, and we see that every single people could have up to 10 devices. On my home, I have TV on Wi-Fi, AC on Wi-Fi, 4 thermostats, let's say on Wi-Fi, phone, few computers, and so on. And my family, I think more than 10 devices are the internet. So that means, in general, in case in the world we are already milliard, 8 billions. Okay, maybe not everyone has a phone, but in average, it will be a kind 1-2 devices per hour. So we have more devices than people already in the world, and everything is connected now. Now, nobody even count because we know that technology is rising by exponential, flow, but nobody already don't care what is the law, because now it's exploding, it's an exploding chain. So now let's speak about the smart city, and let's play the same game. What means a smart city? City that is taking care about us. Yeah, it is analyzing and making some conclusion and provide some action according to the conclusion. So in case I'm speaking on the phone, city will detect that I'm in danger, will stop the car to let me go, or just will stop me somehow. It will find, it will analyze, and will make something according to its conclusion. Is got it? Yeah. So now let's go further. Okay, now going back, so we exploded in the internet, but let's go back in a car. And now I have an information, but as I told and I repeat, I have to add every year 1 year, but it's about 15 year, maybe 20 year already should be, when somebody from Continental come here to find for some smart people. And then their speech, they told, you know, but it was in 2007, something like that. A modern car has up to 40 microcomputers on board. Now we see, most probably you've seen that in the car we have computers everywhere. In how to say, the hand we have a microcontroller there, and every bulb we have a microcontroller everywhere. So we can have even 100 on up to 200 computers, microcomputers on a single board. Now, when you buy a car, you don't have only one device or two. You have a complete network, an intranet, a very complex network that is working on very high speed. Okay, so now this is another example now regarding the application, and here we have some references. When we are defining something like you will do now in problem-based learning internet things, this thing or this system or this solution shall be usable for something. Otherwise, this system you will use only you, or who will buy your system? You, maybe your mom, your wife, if you are married, but nobody needs that because it doesn't cover, doesn't solve a problem. So now we see that we have to solve something. Here is a kind of example, but we see we have the field here, we'll have to collect information somehow, and we have an edge node. Usually I say this is edge computing, that we are computing on the field on a small computer. All the data we are transferring somewhere in the cloud, and we'll have cloud computing. Edge computing, that means computing on the edge, on the field. Usually we have a preliminary information, we just analyze what is important, what not, and send back. In case I need a fast reaction, I will react on the edge. In case I need some bigger analysis, I will send it to somewhere in the cloud. In the cloud, what I will have? In the cloud, I will have some backend or some artificial intelligence. I don't know what is there, but will analyze the information. I will have front end. And this front end, I will provide to everyone to be able to use the system. So now we see here I can order. I want on a salad only from potatoes from these coordinates. Yes, it's possible somehow. Yeah, but this kind of task actually will be, and okay, it's about the Internet of Vehicles. Oh, better to fast. But let's see what is here. What are the subjects here? Internet of what is? What is thing here actually in terms of internet? We have some fields and we have a river. Now the field say, I'm thirsty. Okay, I will bring you some water. So this is provider, this is consumer. The fields are placing some request. This one is serving this request. But not itself, but we will embed some technologies, and field will be able to provide some request and some technology to be able to transfer the water. Yeah, so this is about what is an embedded system. about the Internet of Things, but industrial Internet of Things. So now we see that, okay, as I told, what is robotics actually? Did you hear about the term robotics? What is a robot? What? No, what is a robot? That is replacing human labor. Now we know that until now the term of robotics definition was it has a physical shapes. Now we are removing because we see that there are a bigger amount than in real life. We have a software robots, yeah? Chatbots. We say this is a robot. This is doing, is thinking about that, analyzing and providing some. So it's replacing us in thinking. So you can replace an how to say user in Facebook. Just build a user and it will think, analyze, and it will sometimes will provide some good information or some good conclusion. Sometimes for us, but is replacing some people. So now for the robotics, we don't have any more constraints. It has to be. It should have an physical shape. So now we see that in the industry, everything is automated. That we have some machines that are replacing human labor. Now, actually, it is so automated that we have industry 4.0. Actually, we go to even the next level, 5.0 industry, but it's about I want a square phone. Okay, but I don't know. But you will place this request to the manufacturer. It will build system without any human intervention. Your product. You just have to what? To express your desire or to write some requirements according to what actually you want. And it will build exactly what. So you don't have even to think about the shipping. Shipping could be automated. Everything could be automated. Yeah. So now it's about the total or full industrialization. So people or humans has to use the main features or main abilities. What is the main ability of human being or humans? What? What to do? Okay, to think. Imagination, yes, but it's to think because what cannot be automated? Could you say me what could not be automated? Give me some example. You are living? Why, but why you are living now? So what could not be automated? What?
Emotions.
What? Give me a definition. Because it's saying something, but what could not be automated? Because if I know something, I can define it, and usually we are automating some behavior. Okay, what could be not be automated? Emotion. I don't know how to automate emotion because it's about the state, it's not the behavior. Emotion is the state. Let's say some behavior, all the human behavior, human labor is automated. All the human activity, or all the activities are automated. What cannot be automated? So from the moment we know what to do, we have a sequence of action. We define what you're doing. I'm doing this. So I already know. I define, so it can be automated. Everything we know can be automated. But what cannot be automated? The things that we don't know. Yeah, it's strange, but please give an answer what ChatGPT doesn't know. What ChatGPT doesn't know? doesn't know because he's using databases. Everything was registered once upon a time, he can use that, but he cannot go out. Let's say, now I'm teaching here because, I don't know, because it's time. So such relation, ChatGPT will not do because it's trying to usually interpolate information and it's going, let's say, try to reduce the error between what I want. And usually I'm expressing, I can say if that is correct or not, so he will change his definition according to that. So I'm providing him the knowledge and he provides. So this is actually why machines need us. They don't know a lot of things and they can't think like us. But let's go. How much time we have till the end? 15 minutes. Okay, let's go. But let's think about embedded system and from the system point of view. What is a system? From the structural point of view, it's a collection of components that are behaving or working together to provide a result. And this system has a very complex function that is analyzing information and providing conclusion. It has an input. Now this big function can be split in many simple functions. Why? What is the scope of that? Why we are doing that? Because let's imagine when you are solving a very complex equation or not exercise, expression, what you are doing first? You are solving the parentheses. So we can say we'll have parentheses A, B, and so on. I split it in many simple relations so I can solve. Otherwise, I will not. Maybe somebody can multiply big numbers, but it's only one operation. Imagine this is very complex. Now, to build some system, usually what we have to do? To split this. So now we can say that a system is a collection of components that are working together to provide a result according to those components according to their so now let's think what is internet. Usually we see internet like when we are thinking about internet, we see some devices that are connected together via an internet. Yeah? But when we try to think, we are going to see from another perspective. A system, usually it's one piece, it's like this. Yeah, now let's imagine that the whole internet is placed on one board, PCB board. Now I want a part to be in the United States. What will be? I'll have to cut it, send it somewhere, and now what will happen? I will lose the connectivity. So now I will use the connectivity technology, connection technology, or internet connection to bring this part back to interconnect that. So that means when we are thinking about the system, we have to somehow make an abstraction of the internet. We say that the component A shall transfer information to component B and will have direct interconnection. Usually we'll have established a kind of connection or socket or something like that. I don't know what a session. Yeah, you establish a session, but after that you will use only one interface, not considering that you are sending information. When you are sending a message, you just push the button send. You are not every time thinking on which network and somehow. Yeah. So when we are thinking about the system, we have to think that it is one system, but it's split in many or spread out, and all the connectivity are established, or we are recovering broken lines via internet. And internet is just a technology, is not the scope of the Internet of Things. Internet of Things is not about the internet, but it's about to put many things together to solve a problem. So internet is just a technology. So now when you speak about, let's say, one device, yes, it's a collection of components that are working together. Now, according to our needs, we can say we have a component for acquisition, we have a component for actuation, we have a component for user interaction. So we will give some scope for every component. We'll have a separate component. So all the functionality for the acquisition will place in this part, and so on. So we will give some definition for every single component. We'll not see any more components like here. Yeah, this is a very generic one. We will try to bring some scope for every single component. We'll give names and we'll define the scope of every single component. Now we will go to user interface. We'll see that we will have operating systems, sensor for acquisition, diagnosis, that we will identify some troubles, yeah, and the actuators, protection, we'll have a separate lecture on that. Control, we'll see what is the interaction. I see that something is not good. Let's do something according to our conclusion. Communication to interconnect through the devices. Cybersecurity, of course, it's something not new, but it's about how to protect device against the people. Yeah? Because now we see that we have to secure all the devices. And what architecture actually means. When we are speaking about the architecture, there are also many definitions about the software, hardware, but better to have this view. When we are thinking about the architecture, we should imagine like architecture of a house. We have components, our rooms, yeah, and we have some interfaces, and they see that this room is interacting with this via this door. So we'll say this is an interface, and this room, even it is close to this room, it doesn't have interface. So we have components and interactions. So from the point of view from the static point of view, we'll have components and interfaces or interactions. Okay? It's about the structure or structure. Most probably you remember structure didatic algorithm. So about the data structure, we can have data structures, yes, but this not data structure. Yeah, we have component A, component B, component C, component A interact with this one via this interface. We have another layer of interaction. Let's say from the point of view of electricity, we have different interactions. Yeah, we'll have another interfaces. We see that this one interacts with this one and so on. So now, okay, but let's see how we will do something like here. So now we have a building here. We have floors. Yeah, and from the point of view of a building, we have different components, and every single this component will have floor. So but we will discuss on every single topics. We see that this component interacting with this component. This is the interface, and now this one is the system architecture, and I see that I have a service layer that is interacting with every single server, sensor, and providing some information to device control, to diagnosis, and so on. I have different rooms, and in those different rooms, I implement special features. So most probably you heard about the unit, or unitary test maybe. So what is a unit? A unit usually is a file or a collection of functionalities on the same topic. A component is a collection of units because it's a bigger component. So now we'll say we have sensor components, we have sensor layers, but this abstraction is a system architecture. Now going here, what we see here is a layered architecture. We have the hardware abstraction. So now when we are looking to this diagram, we'll see. 5 minutes? Okay, we have microcontroller. Now I have to handle microcontroller. Maybe if I will learn, if this subject or this lecture will be about the microcontroller, maybe I will think about how to configure that. But when I'm speaking or I'm learning system level, I don't care what microcontroller. For me, it's just computer that is doing something. So I have a hardware layer. I will need some software abstraction layer or a driver of the microcontroller. Now, most probably on the first laboratory work, you already used Arduino.h. What is Arduino.h? Is a driver for the microcontroller or HAL, hardware abstraction layer for the, or MCAL, microcontroller abstraction layer. You don't have to think about how to configure these peripheral models, the ADC, GPIO, and so on. You will just an interface, digital read. So we have interfaces for analog read, digital read, digital write, and so on. SPI, you'll have this interface. According to architecture, we'll have some components inside, but we'll have this kind of let's go further. So now I will buy some components, hardware components from the eBay, some sensors and so on. Now I can write some software, or I can include some drivers or some libraries that will just include sensor.h or DHT 11.h. What that means? I included or I'm using a driver. So now this I buy, this I include, and what I have to do usually only the service layer and application layer. So now as a system, I don't care what is below. From the system, this is more important for me. Everything else I will buy. Good idea? So if I have some hardware, I should have a driver for that. Maybe somebody on the lower level will do some low-level programming. What we are thinking about is how to build some services on the system and applications. So all the laboratory work, I don't care if you are doing something like this. I care if you are properly managing and organize this architecture. On laboratory work, the most important you to structure, to define such diagrams and to structure your code according to the design. So first design code, for me, source code is just an annex, because in case you are defining everything, you can always outsource your project. Somebody. So now this is another type of architecture. I have free degree of freedom kinematics. I just can buy or include some libraries, but I know that I want to do something according to the interface. I have to build these interactions. But after that, we'll see that an architecture will have some dynamic behavior, static view, and dynamic behavior. And most probably you know everything about that from you had some subject like UML language, yeah? Please use them properly. From the system point of view, I don't care even if you are following UML rules. All I want to see on your works that you can draw something that I can understand. Usually I say this is architectural concept. Now going on the software, but software for me is on the system level. On the software, maybe you have to follow the rules of the UML. On the system level, we have to do something like this. So now, something like that. Okay, those are the examples case, is this correct?
Yes.
Okay. Then we have 3 minutes. Let me go. Now, in case you don't know what to do, or most probably you'll go to a company, most probably you already will have some infrastructure like this. And one of the very interesting approach was and the solution was in AUTOSAR, automotive open system architecture. And the problem was that one vendor of vehicles, let's say, has some technology. And imagine that I have some technology that I want to sell. Let's say BMW has a very good radar algorithm and infrastructure. He wants to sell that to Daimler, Mercedes. Now, and the problem was that this solution cannot be integrated directly from one car to another car. Why? Because it has different approach, different interfaces, different architecture. Now they stayed together, many people like this, and told, let's have a standard architecture, standard interfaces. So after they defined this architecture, they say, okay, we'll have 3 layers that will say microcontroller layers, ECU abstraction layer, and services. And let's have some stacks. Most probably you heard about the stack, TCP/IP stack. We have a stack, we have layers. So for them, we'll have communication, crypto layer, what is here, memory layer, and so on. Now they defined all the interfaces of these components. And from this point, not only these people was developed the software for the automotive industry, but we see here there are a lot of companies that started to develop only some parts. So that means architectural approach. Could you wait a few minutes? Okay. So now what that means? I have a company that is doing the best this component, but another company that is doing the cheapest solution for that. Another one is time. So now, depending of my requirements, I can select me as a OEM, original equipment manufacturer, or how to say. So I can use solution from different, and I can build that. Let's say in 19, let's say one car was developed in 5 or 7 years. Now did you see that? Did you realize that every single year we have a new models of cars? Why? Because they just build them from parts. Why? Because we have a lot of companies and everyone is doing them. But how they can build them together? Only by defining clearly standards and interfaces. So architectural approach and embedded system is the key of the success. Okay, that's all for today. Please give me the appendix. Time.